in-house we have Dr. Joe Pollitt, whose main primary focus is researching sponges and their chemical compositions. And as I've talked to him in the past, there are so many different natural products that are derived from marine species. And the last time I talked to him, he said there's over 21,000 natural products that have been derived from marine organisms of various kinds, that they're used primarily in things like cosmetics, skin care, and the main one that everybody's concerned with is pharmaceuticals, and that's what he is researching. But there's so much that we haven't discovered yet. But these are all things that, of those over 21,000 products, if we didn't have scientific diving, we wouldn't be able to accumulate anywhere near that number. And other ways that we've seen, that I've seen scientific diving advance exploration is several years ago, back in the early 2000s, we had a project where we were helping to map the wreckage of the USS Monitor, Civil War ironclad, and that sank in 230 feet of water off of Cape Hatteras. And at that time, they wanted to salvage large parts of it, including the propeller, the shaft, the turret, the actual revolving turret, which was the first revolving turret ever put on a vessel, and also the engine needed to come up. And they used divers. They used divers from our program here to actually go in and do the preliminary mapping before any of these items were removed. And that would have been next to impossible with a remote operated vehicle. You just can't do it. You need to have hands-on. The ironclad is upside down. It's in 230 feet of water. Some of the spaces were very tight to get into and map and measure. And that couldn't have been done without scientific divers. And if we weren't able to measure that in place, the marine archaeologists would not have given the Navy permission to actually go and remove it and to place it in conservation in the museum. So these are two of the things that just focused by UNCW that have captured marine discoveries by using scientific diving.
An ROV is a remotely operated vehicle. That means it is tethered to the vehicle or to a vessel via an umbilical that is could be a different distance, could be a very short one, it could be a very long one, and it is controlled by from the surface of the ocean on the vessel via an operator. ROVs are very important in the field of scientific diving for many reasons. One main reason is ROVs can go to very deep depths. The typical diver really can go to 130 feet, and the ROV can go anywhere from 100 feet down to several thousand feet, several thousand meters. The ROV can also collect samples and do most things divers can, and can also put different instrumentation on ROVs to collect different data, whatever the primary scientist needs at that point in time. Now that ROVs are around the world, exploration can be done in places that it could not be done before. Like I was just saying, in the water depth for divers, 130 feet is the typical max depth for a regular diver, and it could be up to 1,000 feet with specialized commercial diving. But now with ROVs, people are researching in the deepest parts of the ocean and finding different sponges and corals and different habitat. So now that ROVs exist, people are doing a multitude of deeper depths dives and longer dives and things like that. Some other things that make ROVs special are they can actually do work. So like a human being, you can attach different manipulators, which are robotic arms on the ROV. And with that, you can actually screw nuts in different devices on like a drill rig, or you can do all types of work. You can pick up samples from the bottom of the ocean and collect them in a bin and bring them to the surface, or different things like that. The main reason you use an ROV over a human diver is because of water depth. Divers only go 130 feet or a little bit more than that, and ROVs can go very deep. I guess the other main reason why ROVs are better to use than human divers are because they can stay down for an infinite amount of time. If you're taking a diver to 130 feet, they may only have 20 minutes on the bottom, then they got to come up and start decompression. Now, as a ROV can stay down for several days at a time, as long as you have as many operators as you need to drop the ROV.
I'm a marine electronics technician, so I'm responsible for deploying and maintaining a lot of specialized electronic equipment. In most cases, the pieces of equipment are very sensitive and require a very gentle touch when they're being deployed. In some cases, the equipment has to be deployed in a particular orientation or at a very specific location. So scientific diving allows me to have a tool where we can actually make sure that the instrumentation is set up correctly when it's deployed.
I do a lot of scuba diving. My work is entirely based out of the Caribbean, and I'm asking a research question that requires scuba diving. So I want to study coral reef communities, and the part of coral reef communities that interests me are the sponges. So when you think of sponges, there's lots of things that come to mind that are probably not what I'm talking about. Sponges are a type of invertebrate animal that lives on the bottom of the ocean and feeds by pumping water through its body. Now in the water there's plankton, there's detrital material, there's all kinds of food stuff, and that's how sponges feed. They live off of that. And sponges are becoming increasingly important in the Caribbean because stony corals are starting to decline and algae are becoming abundant. Sponges are just now more prominent part of the ecosystem than they were before. And so understanding aspects of their ecology is really important if we want to understand the future of coral reef communities.
Well, scientific diving covers a lot of things in diving. You can do scientific diving for research, marine biology, marine geology, learning scientific method is part of scientific diving. So it really covers a lot.